All right, guys, I'm going to go over the study guide today. So make sure that you are corrected your study guide as we go, because I saw a lot of mistakes. So remember, just because you got 30 out of 30 on your study guide when I graded it, if you turned it on time, does not mean it was all correct. It just means you made a solid attempt on almost all the problems. All right. So remember, we are evaluating, right? That means we're going to follow the order of operations. And we're going to go from parentheses down to subtraction, right? Remember, I always do addition, subtraction left and right, and multiplication, division left and right. So it is not solving, it's evaluating. So number one, 24 divided by 3, that's division. I do that first to get 8. 2 times 3 is multiplication. I do that before I do my subtraction. So I end up with 8 minus 6 is equal to 2. Number 2, same exact thing. I see an exponent. I do exponent before addition. So I have 5 plus 4. Now I can do my addition to get 9. 3, a lot of people use distributive property here, which is not wrong. I would never do that with only numbers. If that was like an X, I would have to use distributive property. But because it's just numbers, I'm going to do inside the parentheses first. 3 plus 9 is 12. Now I can do 4 times 12, which is 48. Remember, a number next to parentheses always means multiplication. Right? Number 4, 1 plus 3, I do that first. So I do my parentheses first, so I end up with 4. Now, I didn't do anything with the exponent, so that's still there. I didn't do anything with the 2. It's still there, and it's still 36 minus. So I have exponent. I see an exponent. I see multiplication because 2 next to 4. I do exponent first. So my next thing I'm going to do this exponent part. I end up with 16. Now it's in parentheses. So I have 36 minus 2. 2 next to 16 is multiplication. I do that for subtraction. So I end up with 36 minus 32. Now I can finally do my subtraction, and I end up with 4. That's it for number 4. Now remember, on 5, there is implied parentheses around the top and the bottom. So basically, you do the top first, then you do the bottom, then you do top divided by bottom after everything's done. So I'm going to do my exponent first on top. So I have 40 minus 8, because 2 times 2 times 2 is 8. Now I'm doing the bottom. In the bottom, I do the 2 squared first. So I have 4 plus 3, and then 2 squared is 4. Now I'm still just going to go back and look at the top. 40 minus 8, I'm allowed to do the subtraction. So I have 32. In the bottom, I'm doing 3 times 4 first. So I have 4 plus 12. So I end up with 32 all over 16, and that's going to simplify down into 2. Number 6, same exact concept. Remember, there are parentheses basically around the top and the bottom, so I do the top all by itself first. The top is going to become 40 plus 8. The bottom, I'm going to do inside the parentheses first. So I end up with 4 minus 3, and instead of 2 squared, I put 4 because I did that first. Then I'm going to do 3 times 4. So I end up with the top is going to be 48 because I do the top and bottom separate. And the bottom is going to be 4 minus 3 times 4 is 12. So I end up with 48 all over negative 8, which simplifies to negative 6. These are not solutions because I don't have letter equals a number. So even though there's an equal sign that showed up at this last bit here, right, that doesn't mean that it's letter equal a number. Right? That's it for evaluate. All right, we're going to do the distributive property or undo the distributive property. So basically, if we see parentheses, right, you're going to make them go away. Undoing the distributive property basically says if there's no parentheses, you're going to make them appear. All right, so remember I call this pizza delivery guy. So number 7, 6 is the pizza delivery guy. He's going to go over to X's house, 6X. Then he's going to go over to minus 3's house, becomes minus 18. Done. That's it. 8. Guys, just remember, with multiplication, 3 times 2 is the same thing as 2 times 3. So that means it doesn't matter that the n is on the left. You're still going to distribute. So n is going to go over to x and turn to nx, and then the n is going to go over to y, turn to ny. That's it, done. Now, number 9, I only wrote it like this to try and help you. It's very unlikely that you'll ever see something look like that. It'll probably look more like that. And you would have to realize that 28 is divisible, turns into 4 times 7. Because when the parentheses are gone, you have to figure out who was the pizza delivery guy, or what was in common between the two. So if I look at it, both of these were multiplied by 4. So if they have something in common, those two matching 4s come out and turn into 1 4 as long as whatever is left over goes in parentheses. So basically, we're just working backwards from what we did in 7 and 8. So number 10, no parentheses in the problem. So I know my answer is going to have parentheses. I find out what's in common. So the n shows up. Now look, at the n, I'm left with m minus 3. That's it. All right, remember, on 11 through 14, just like 7, 8, 9, and 10, there is no equal sign. This is not a solved problem. So your answer will not be letter equals a number. Right? This is where you're just going to make the parentheses go away and combine like terms. So remember, with number 11, if this makes you feel better because you put a 1 in front of there, that's fine. So the second set of parentheses turns into -1 plus d. The first set of parentheses, nothing changes because there's nothing in front of that parentheses. So 7d plus 1. Now I'm going to combine my like terms, letters with letters, and I don't know why I wrote a 2 there. That makes 0 sense. So I want that to say plus d. That's a terrible, terrible mistake. All right. So letters with letters. So 7d plus 1d is 8d. 1 minus 1, they cancel. Done. 12. Remember, nothing in front of that parentheses. So the negative turns into both. The most common mistake I see here is everybody thinks that a negative in front of parentheses makes everything negative. That is not the case. The negative just change the sign. So it's a positive 5a, now it's a negative 5a. It's a negative 5, now it's a positive 5. And then the first set of parentheses, nothing changes because there's nothing in front of there. Now I combine the terms. 2a minus 5a is negative 3a. Negative 1 plus 5 is plus 4. Done. That's it. 13, same exact concept. The minus sign makes the minus 4x plus 5. The plus sign doesn't change anything. So just like a lot of people think the minus sign makes everything negative, which is not true, the plus sign doesn't do anything. It just keeps it exactly the same. If you want to think that it's just multiplying everything by 1, that's fine. And then this first set of parentheses, there's nothing in front of it, so it can't change at all either. So now I put x's with x's. 2x minus 4x is negative 2x. Negative 2x plus 6x is 4x. I just cross them out so I don't accidentally use them again. You don't have to cross them out. 3 and 5 is 8. 8 minus 7 is 1. So 4x plus 1, done. Remember, there is no equal sign. That is done. So we're not solving these. All right. 14. I'm going to distribute. Remember, the first set of parentheses is not going to change. I have minus 8y plus 1 minus 7 plus y. I end up with 4y plus 9 in the first set of parentheses. And now I put y's with y's, numbers with numbers. 4y minus 8y, negative 4y. I messed up. 4a minus 8 is negative 4a. I didn't mess up. I've been doing it all in one step, and I was going to take 2 steps. 4y minus 8y is negative 4y, plus another y is 5y. 9 plus 1 is 10. 10 minus 7 is 3, and we're done. All right, so remember here, when we plug and chug or evaluate, the first thing we're going to do is we're going to rewrite this. So I'm going to rewrite the entire problem, but wherever I see a variable, I'm going to put an empty set of parentheses. So I'm going to put parentheses because that's in the original problem. 3, instead of x, I'm going to put an empty set of parentheses. The other parenthesis bar, squared, minus 7, instead of y, I put parentheses, squared. Now, wherever I see an x, I'm going to put 3, so I put 3 right here. Wherever I see a 2, or a y, I'm going to put 2, so I put 2 there. And that's just order of operations problem. So remember, you have to do inside the parentheses first. I saw a lot of mistakes here. You have to do 3 times 3 first, which is 9 squared. And here you're going to do the exponent first. So you can't do 7 times 2. You have to do 2 squared because that's an exponent. Just because the 2 is in parentheses, the 7 doesn't matter. Right? Only if the 7 was inside the parentheses with the 2. So it's minus 7, and then 2 squared is 4. Right. So I'm going to do the other exponent, 89 squared. So 9 times 9 is 81 minus 28. I'm going to end up with 53. 16, exact same concept. I just changed the x's and y's a little bit. So I have parentheses, 3, parentheses. I'm going to put negative 3 squared minus 7 instead of y. And I actually shouldn't have put that. I'm kind of skipping steps. So remember, the first thing I do is I write it with empty set of parentheses first, just to not confuse anybody. Then wherever I see an x, I'm going to put negative 3, so I put negative 3 here. Wherever I see a y, I'm going to put negative 2. Put negative 2 there. Once again, I do inside the parentheses first, so I do that 3 times negative 3. It is negative 9 squared minus 7, and then I'm going to do the exponent, so it's negative 2 squared. I picked this problem specifically to see if you've been paying attention about parentheses around the negative number before you square it, because a negative 2 times a negative 2 is a positive 4. Same thing when I square negative 9, it's in parentheses, so it should spit out positive 81. So believe it or not, these are both going to give me the same answer, 53. If you can read that, 5. 17, exact same concept. 4, empty set of parentheses for the y, minus empty set of parentheses for the x. 3, the parentheses that's in the problem. 2, empty set of parentheses for the x, plus empty set of parentheses for the y. Remember, this is what I talk about, where x is your starting quarterback. He broke his leg. He's got to leave the field. Negative 3 is his backup. He's going to go in his spot there and there. The running back also broke his leg. So I'm going to put 3, his backup, in there and there. And then this becomes an order of operations problem. Remember, technically, there's parentheses around the top and the bottom, so you have to do the top and bottom separately. So on the top, I'm going to do the multiplication first. So 4 times 3, which is 12, minus a negative is adding all over. Inside the parentheses, I'm going to do 2 times negative 3, which is negative 6. Add the 3, so I'm going to have 3 from outside the parentheses on the bottom. And then inside the parentheses is negative 6 plus 3, which is negative 3. So I'm going to end up with, the top is 15, the bottom is negative 9. So I'm going to end up with negative 5 thirds. 18, exact same concept. So 18, 4, empty set of parentheses, minus empty set of parentheses, all over 3, 2, empty set of parentheses, plus empty set of parentheses, close it. Wherever I see an x, I'm going to put a 3. So wherever I see an x, I put a 3. So I put a 3 here and here. I put a y, negative 3, there and there. Once again, I do the top first, bottom by itself. I end up with negative 12 minus 3. So I have negative 12 minus 3. The bottom becomes 6 plus, so I have 3 from outside the parentheses. I do in here, 2 times 3 is 6. 6 plus negative 3 is positive 3. So this is going to be the same exact answer, but now it's negative 15 over 9, which is still going to turn into negative 5 thirds. And that's it for 18. All right, remember, now we are solving. So this is the first time in this entire study guide that you're going to be using Pemdas in reverse. So remember, we do the order of operations from parentheses down to subtraction when we are simplifying. But when we're solving, we go backwards. Right? And remember, the addition and subtraction undo each other. Multiplication, division undo each other. When we get to exponents, we're going to talk about radicals and how they undo each other. Right? So I look at 19. Remember, the biggest key here, too, is this is for one variable. Right? So this is for one variable. It's a little bit different when there's multiple variables, and we'll go through that. So I see one variable right here. So the first thing I do is I look for subtraction. I see subtraction, minus 7. How do I get a subtraction? I add 7 to both sides. So I end up with 4x equals 36. Subtraction's gone. I don't see any addition. I don't see any division. I see multiplication because that's 4 times x. How do I tell you to get rid of multiplication? By division. And that's why I divide by 4 on both sides. I end up with x equals 9. Like I said, if you want to check your work, plug it in. 4 times 9 is 36. 36 minus 7 is 29. It does work. So anytime you're lost, I'm going to use, that's your hint. Pemdas backwards, right? Anytime you're lost. So if you're lost on number 20, it's a solved problem. You put Pemdas backwards, right? Just remember it's supposed to have one variable. One variable. This one does have one variable, just an S. So I don't see any subtraction. I see addition, the plus 29. How do I tell you your addition? Use subtraction. So I minus 29 from both sides. I end up with 7s equals negative 49. There's no addition. There's no division. Multiplication. How do I tell you your multiplication? Divide. So I end up with s equals negative 7. Done. That's it. Like I said, if you want to check your work, go ahead. 21. Same exact concept. Pemdas in reverse. If you're struggling, it already has one variable, so I'm allowed to use Pemdas. I don't see any subtraction. I see addition, so I minus 9 from both sides. Remember, the red writing is me choosing what to do. I can choose whatever I want to do as long as you do it both sides. I end up with 15n equals 12. Now, the addition's gone. I don't see any division. I see multiplication. So to get rid of that, I divide both sides by 15. Notice the 15's on the bottom. So I have n equals 12 over 15. Now, 12 over 15 is okay, but it can be simplified. I'm going to divide the top and the bottom by 3. So my answer would have been 4/5. I would grudgingly accept 0.8. So that's it for 21. 22. Now, once again, when I talk about Pemdas backwards, I talk about this idea of one variable. Now, I have an x here and an x here, so I'm not ready to try and solve yet. I don't try and solve yet. Basically, what I'm going to do is I'm going to distribute the negative 2 on the left side to get negative 2x minus 12 equals, and on the right side, I'm going to do the exact same thing, 2x minus 8. Now, I'm going to get all my x's on the same side so I can have one variable. So it doesn't matter to me which side you move the x's over to. I personally always move the smaller of the two. So I see negative 2x, so I add 2x to both sides. I chose to add 2x on the left side because it makes that guy cancel out. So I end up with negative 12 equals 4x minus 8. Now I'm thinking about Pemdas backwards. Okay, there's subtraction. How do I get a subtraction? I add 8 to both sides. I end up with 4x equals negative 4. Subtraction is taken care of. I don't see any addition. I don't see any division. I see multiplication. It's a 4 next to the x, so I divide by 4. I end up with x equals negative 1. And that's it. 23, exact same concept. All right, I'm going to distribute. So I end up with negative 12x plus 4 equals, on the right side, negative 10x plus 40. Negative 14x doesn't do anything. It's just hanging out there. Now, when I'm thinking about Pemdas in reverse, I do not have one variable yet. I have an x here, I have an x here, I have an x there. So I have 3 x's, and I actually have 2 on the same side. So before I do not do anything to both sides to make the negative 10 and the negative 14 cancel out or anything like that. I just put them together because they're on the same side. It's just combining like terms. So I just do negative 10x minus 14x becomes minus 24x. I don't like that in red. Let's make it green. I always like to do red for you guys whenever I'm doing something to both sides, so I don't want you to get confused. Negative 10x minus 14x is negative 24x. I didn't do anything with the 40, and I didn't do anything with the left side. So that was just combining like terms. It was not doing anything to both sides. Now I look at my x's. Negative 24 to me is smaller, so I'm going to add 24x to both sides, although it doesn't really matter. You could add 12x to both sides. As long as you do it to both sides and you do it correctly, it doesn't matter. So I'm going to have 12x because negative 12 plus 24x is 12, plus 4 equals 40. Now, after all that work, I'm finally actually thinking about Pemdas in reverse, or Pemdas backwards. I don't see subtraction, I see addition, and that's why I'm minus 4 from both sides. I end up with 12x equals 36. The addition's taken care of. There's no division. I see multiplication. That's why I divide both sides by 12. X equals 3. That's it. Done. (24) and 25, exact same concept. So like I said, I'm not even worried about Pemdas backwards yet. The first thing to do is I'm going to distribute the negative sign. Remember, it's a -1 if you need that there to make your life a little bit easier. So on 24 becomes minus x, or minus 1x, minus 2. Minus 2x equals, I'm going to distribute on the right side, minus 2x minus 2. Now I'm going to combine my like terms. On the left side, negative x, negative 2x, they come together to become minus 3x, minus 2, nothing happens. Now I'm going to put all my letters on one side, so I'm going to add 3x to one side. If I do it to one side, I have to do it to the other. I end up with negative 2 equals x minus 2. Now I'm going to add 2 to both sides. The reason I'm going to add 2 to both sides is because I want to get rid of the subtraction with the x. So I end up with 0 equals x, or x equals 0. This is an answer. This is not one of those true or false questions, no solution, infinite solutions. This is one answer, x is 0, right? The letter did not disappear, right? The only time that you worry about that is if the letter disappears. 25, exact same concept. First thing we do is distributive property. So negative 4 is going to distribute. So I have negative 12 minus 4x plus 5 equals 4x plus 12. I'm going to combine my like terms on the left side first. So negative 12 and 5 go together. So my problem is going to become negative 4x. I just like to write my x first. Minus 7 equals 4x plus 12. Now don't automatically think because I see a 4 on both sides that these are going to cancel out and it's either going to be 0, no solution, or infinite solution. That is not the case here. Remember, I move the smaller of the two, so I see positive 4x. I see negative 4x, so I add 4x to both sides. And the left side becomes negative 7. The right side becomes 8x plus 12. Remember, now it's just a regular solve problem. So if you're struggling, this is where you put Pemdas backwards. I see no subtraction, but I do see addition, so that's why I'm minus 12 from both sides. I end up with negative 19 equals 8x. No addition, no division, multiplication, divide by 8, divide by 8. X equals negative 19 all over 8. Now you can write negative 2.375, negative 2 3/8. I just like to leave it as an improper fraction. All right. Now, rewriting is very similar to solving because we are going to solve for a letter. We're going to use all of our solve skills. That means like you get rid of addition with subtraction and subtraction with addition, but you will not get a number answer. You will not have letter equals number only. You're going to have letter equals stuff. It's going to be some sort of other variable. All right. So remember, the biggest mistake I see here is that people forget to label. Don't forget your labels. Or you have to tell me that you're purposely going to get y by itself on one part. In part B, you're going to get x by itself in another part. Right? They're two separate things. So 5x minus y equals 10. I am telling you to get y by itself. Right? When you're telling me, when you write 4y, that you are purposely getting y by itself. So there's a couple different ways to do it, but like I said, the easy way for me is say, I want y by itself, which means I want this minus 5x to leave, or I want 5x to leave, so I subtract 5x from both sides. Right? Now I have negative y, and if you have to put a 1 there so you don't make a mistake, that's fine. It is really negative 1y equals, and I like to write my x first, so I put negative 5x plus 10. Now y technically is not by itself because of that negative sign, so I do have to divide every piece by negative 1. Once I do that, I end up with y equals positive 5x minus 10. Y is by itself, so I have y equals some stuff. It's the exact same concept for x, I just am doing it with the other letter. So I still have 5x minus y equals 10, but now I only care about that x right there. So the first thing I do is I got to add y to both sides because I want the negative y to go to the other side or cancel out. So I have 5x equals, and I like to write y first, y plus 10. X is not by itself, so the way to get x by itself is I divide everything by 5. I end up with x equals y over 5, or 1/5 y if you're thinking of slope-intercept form. 10 over 5 is 2. That's it for 26. So all the problems, 26 on this page, 27, 28, 29, etc., will look exactly like this. So if you don't have a label, you don't have at the end y equals some stuff with x on the other side, x equals some stuff with y on the other side, you're making a mistake. All right. So here we go again. I'm going to get 4y. I'm going to get 4x. So I have x plus 4y equals negative 8. Remember, I want y by itself, so I'm going to subtract x to start. Now remember, where people make mistakes is they think that 8 and x can go together. They can't. I have 4y equals negative x minus 8. Order does not matter. You can put minus 8 minus x. Now y is not by itself yet, so I divide everything by 4. I end up with y is now by itself. You can write negative 1/4 if that makes you happy. X. The x is not on the bottom. It's either next to it or it's on top with the negative 1. 8 over 4 is 2, so it's minus 2. For x, I write the same beginning equation, x plus 4y equals negative 8. Now this one's really easy because minus 4y from both sides. I end up with x equals negative 4y plus 8. X is already by itself, done. That's it. All right, same exact concept. I'm going to try and fit these 4 on one page. So remember, 28, first thing I'm going to do is I'm going to label what I'm doing. 4y, 4x. I have 2x equals 3y plus 9. I want y by itself. Now what I'm going to do is I'm actually just going to minus 9 from both sides. So I end up with, and I'm going to write the y on the left. So I'll write this actually. 2x minus 9 equals 3y. And then I'm going to rewrite it so the y is on the left just because I like to have the y on the left. And now I'm going to divide everything by 3 to get y by itself. So I end up with y equals 2/3 x minus 3. Now when I do the second one, or 4x, part B, look, y and the number are already on the right side. So the only thing I have to do for this one is really easy, just divide by 2. I end up with x equals 3/2 y plus 9/2. Done. That's it. 29. 4y. This looks like a fire starter question, I bet. $4x. So if you're ever struggling, I mean, this doesn't take a lot of math skill. You just write the original problem. It's the first thing you do. And then you figure out what letter you want to get by itself. Oh, I want to get y by itself? Well, let's get rid of the x. Let's get rid of the 12. All right? So now I have negative 6y equals minus 5x minus 12. I just like to write letter than variable. Now I got to get rid of the negative 6. And I had a question when I went over this on a fire starter. Could you have added 6y to both sides to start? Yes, you could have. And you'll get the same answer at the end. So I was just showing it the more traditional way, but yeah, my brain would have done that also. So there's nothing wrong with that. Y equals positive 5/6 x because of negative over negative plus 2 because of negative over negative. For x, same exact concept. I'm going to add 6y to both sides because I need to get this x by itself. I'm going to minus 12 to both sides. No concept has changed yet. So I end up with, I forgot to write the little y there. So I should have 6y minus 12 on the right side. Now I have to divide both sides, everything by 5. I end up with x equals 6/5 y minus 12/5. And that's it for 29. 30, exact same concept as 29. Exact same concept. Right? 4y. 4x. Don't forget your labels. So many people forgot their labels when I was walking through. So 6x minus 5y minus 44 equals 0. Like I said earlier, somebody said, can I just add 5y to both sides first? There is nothing wrong with that. 5y equals 6x minus 44. And I just wrote the y's on I wrote the right side of the equation on the left and the left side on the right. And then I just divide everything by 5. It is a little bit faster. So I end up with y equals 6/5 x minus 44 over 5. I would have left it as an improper fraction. If you want to give me 8 4/5 because you're thinking about slope-intercept form and you like that b to be a number so you know where it's going on the number line, that's fine. Either way, it's fine. Same thing with x. 6x minus 5y minus 44 equals 0. Somebody asked if they could just subtract 6x from both sides first because they see it's only moving one thing versus in 29 we moved multiple things to start. That's fine with me. And then look, I'm going to write the negative 6x on the left equals negative 5y minus 44. Now I'm going to divide by negative 6. Just remember if you do it this way that you're dividing everything by negative. So I have x equals 5/6y. And actually, I'm going to simplify that into 22 over 3. That's dividing the top and bottom by 3 of that fraction. Right? Now, 31 is actually the hardest. So it's not harder for y, to be honest. So when I do for y, it's actually not much more difficult. It just seems more difficult because there's a little bit more stuff going on. So I have x minus 2xy equals 1. Remember, I want to get this y by itself. So the first thing I do is I subtract x from both sides. I end up with negative 2xy equals 1 minus x. Now, before, I would just, if there was no x there, I would just divide both sides by negative 2. And remember, I'm just going to divide by negative 2x because I just want that x to leave the left side. So I end up with y equals, I'm going to put negative 1 over 2x. The x does have to be in the bottom here. And there's an x on the top and bottom of the right side, so it's plus because of negative over negative. Those x's actually cancel and it becomes 1/2. Now the hard part for this one is actually when we go for x. And that's because x minus 2xy equals 1. There is an x here and an x here. If I add the 2xy to both sides, I'm gonna have an x on both sides. If I subtract x from both sides, I'm gonna have an x on both sides. There's no way to smash those two together because they're not like terms. So we have to do this thing called undoing the distributive property. And basically what it says is if they both have an x in common, you could take those two x's and turn to one x as long as you put whatever's left over inside the parentheses. So look, 2 x's in the first line now becomes 1x outside the parentheses. And even though it's messy, it's got parentheses and stuff, that's just x times some stuff. So to make multiplication go away, I just divide by that stuff. So believe it or not, this is a shorter work, You just had to take a more complicated concept. So the final answer is just x equals 1 over 1 minus 2y. All right, 32 and 33. Remember, they both have fractions, and then you guys get all sad because you hate fractions. But remember, we're going to use this thing called the LCM. So I'm going to write the denominators 3, 6, 7, and 14. And I always start with the biggest denominator, 14. So I'm going to ask myself, does 3 go into 14? Right? It doesn't. So it doesn't matter if 3 goes into 6 or 3 doesn't go into 7. None of that matters because 14 is not going to help me. So then I always mess with the biggest one first, and I try 28. Right? Now, does 3 go into 28? Nope. So it doesn't matter that 6 doesn't or 7 does. So then I try 42. Well, 3 goes into 42. 6 goes into 42. 7 goes into 42. And obviously 14 goes into 42. So 42 is going to be your LCM or your least common multiple. Now, don't make the mistake and forget to multiply this first R by 42. Each piece gets multiplied by 42. This is not the only way to do this problem, by the way. Because this problem, I'd probably add and subtract fractions to make my life easier. But I know you guys hate fractions. So the first thing I would do if you guys hate fractions as much as you do is I would multiply every single thing by 42. So then this becomes 42R. Now, 5/6. So if you're using my calculator, you do 5 ABC 6 times 42. Or do 5 times 42, then divide by 6. Either way, you're going to get 35. Equal sign. 5/14 times 42. So that's going to say 5/14 is going to be 15. This turns into 42R. It's a plus sign. 4/3 is 52, if I'm not being crazy today. 6/7 is going to be minus 36. So the 4/3 turned into that. The 6/7 turned into that. And the negative 5/3 turned into negative 70. Yeah, negative 70. Now, before I go do anything on the right side, I'm just going to combine like terms. 15 and 52 becomes 67. 67 minus 70 is negative 30. Negative 3. Negative 3 minus 36. So the R stays the same. So I have 42R, but then all the numbers, and that's if I did it right. I'm doing it in my head. So double check my math. It's actually not going to matter for this problem, but double check my math. I should have gotten minus 39. And on the right side the left side didn't do anything. And now I'm just going to minus 42R from both sides. I get 0. So those cancel. I get 35 on the left side. Now, the biggest mistake I'm seeing here, the letter is gone. This is not 42 minus 42 is just an R. It's gone. Right? So I get 35 equals negative 39. That's not true. So this is when we say true or false. This is when the letter disappears. So if the letter disappears, I say since false, 35 is not equal to negative 39. It's going to be no real solution. The key word is, or it's actually a phrase, the key phrase that you need for your fire starter is magic math won't help on your quiz. Magic math will not help on your quiz. All right, 33, exact same concept as 32. So remember, we have this LCM we talk about. I see 6 and 15 is my only two denominators. 6 does not go into 15, so I try 30 because that's the next multiple of 15. 6 goes into 30, so I know 30 is the LCM. So I'm going to multiply all the pieces by 30. So I end up with 1/6 times 30 is 5n plus 85 equals 184 plus 60n. Now I'm going to put my n's on the same side. So I'm going to minus 5n from both sides. So I have 85 equals 184 plus 55n. Now I'm going to subtract 184 from both sides. I'm going to get negative 99 equals 55n. Nothing's changed. I get rid of the multiplication with division. And I get n equals negative 99 over 55. Now you can divide the top and the bottom by 11. So the best answer is going to be negative 9 over 5. Negative 9/5. All right, I'm going to pick up the page. I'm going to try to finish this all on one page. So remember, Pemdas backwards is just going back like to the previous page. So if you're stuck on any of this, remember, Pemdas in reverse. We want to have one variable before we do this. Remember, addition, subtraction undo each other, multiplication, division undo each other. So 34, I do not have one variable. So the first thing I'm going to do is I'm going to distribute. So I end up with 2 plus 8m. I didn't do anything with the 6m plus 2 on the left side. I didn't do anything with the negative 2m on the right side. So I should make that a little bit neater. So I have negative 2m plus 2. Now, on the left side is going to stay 6m plus 2. I'm going to combine negative 2m and 8m is equal to 6m plus 2. I already know that this is going to be all real solutions because they're exactly the same on both sides right now. But in case you didn't know that, you just minus 6m from both sides. I'm left with 2 equals 2. Well, that's a true statement. So since it's true, remember, if the letter disappears like it did here, you have to tell me true or false. Then you tell me all real numbers. 35, exact same concept. Negative 6 distribute, so I end up with negative 30b plus 30 minus 7 equals 23 minus 7b. Now on the left side, these are like terms, so I put them two together first. Those are like terms, so I put them together first. So I have negative 30b plus 23 equals 23 minus 7b. I'm going to add 7b to both sides. So I end up with negative 23b plus 23 equals 23. Now I'm going to minus 23 on both sides because remember, I'm going to get rid of the addition just like we've been doing the entire time. Minus 23b equals 0. This is different than 34. The letter did not disappear. We still have a letter. That means I am allowed to divide both sides by negative 23. So b equals 0. 36, exact same concept. 9 is going to distribute. I end up with 18n minus 72 minus 11n equals, the 4 is going to distribute, 4 minus 12n. Now on the left side, before I do anything, I'm going to put those two together. So I'm going to have 9n minus 72 equals 4 minus 12n. Now I'm going to add 12n to both sides. So I have 21n minus 72 equals 4. Now, I'm going to add 72 to both sides. So I get 21n equals 76. I'm going to divide both sides by 21 now. So I'm going to get n equals 76 all over 21. And that's it for 36. $37, I'm going to distribute to start. So I don't do anything with the minus 7x. I distributed the negative 9 to get plus 27x. Distributing the negative 9 to get plus 99 equals negative 9x plus 99. Now I'm going to combine my like terms. So I end up with 20x plus 99 equals negative 9x plus 99. I'm going to add 9x to both sides. Because remember, whenever we deal with solving, I always want to get all my letters on one side. So I add 9x first. 29x plus 99 equals 99. Now I'm going to minus 99 from both sides. I end up with 29x equals 0. Now remember, the letter still exists. So this is x equals 0. Right? Well, that's slightly different. All right, finish it up. Finish the worksheet up. Finishing the worksheet up. Here we go. Distributive property. 2 goes to both. So I have 2b plus 4. Distributive property over here. I have 3 plus 3b. Remember, I didn't do anything with that plus 2b here, the equal sign, or the negative 7. On the right side, I have some like terms. So I'm going to do 3 and negative 7 together to get negative 4. I didn't do anything with the 3b on the right side. On the left side, I'm going to do 2b and 2b together to get 4b. I didn't do anything with the plus 4. Now, remember, I'm not ready to solve yet because I have variables on both sides, so I'm going to minus 3b from both sides. Remember, I moved the smaller of the two, so I have b plus 4 equals negative 4. Now I'm going to get rid of the addition. I get rid of addition with subtraction. So I end up with b equals negative 8. Done. 39. Same exact concept. Distribute. I have negative 9 minus 7n equals negative 10n plus 30. I'm going to put my letters on the same side. Negative 10 is smaller than negative 7, so I add 10n to both sides. Not that it really matters. If you want to do it the other way, you could. And like I said, I like to write my letters first, so I'm going to put 3n before I write minus 9. Now, I can solve. I have one variable, so I'm going to get rid of the subtraction with addition. I have 3n equals 39. Now I'm going to divide both sides by 3 because that's how I get rid of multiplication. I end up with n equals 13. Done. That's it. That's going to finish this worksheet. There is one mistake on purpose, so hopefully you paid attention. There is one of them on purpose, so if you still have not finished your study guide, when I grade it, I will be looking at that one for accuracy. Remember, the key phrase is magic math will not help you on your quiz.